Excellent. Cool. So thank you all for coming out. My name is Mauve. My pronouns are they, them. And today I'm going to be talking about a holistic approach to local first software. This is going to be a pretty high level talk, so I'm not going to be getting super into the technical details of things. So if you have any questions or see a term you don't know, feel free to save that for later. Maybe reach out in the DMs or meet me in the hallway track. So I missed a slide. So what does holistic local first even mean? So to start, it consists of local first software, which is software that works offline first, that scales with local networks and up to the internet. It's software that preserves user agency and gives users control over their data and how they access the software. But outside of local first software, there's also local first infrastructure. So in particular, that's community run infrastructure for physical networks or for services and the such. And this also interacts with just local first approaches to community governance, where rather than having big centralized decision making from up top, it's more of a bottom up approach. Oh, okay, yeah, the Steam Deck is not going that well. So what are the parts of this big picture? So I'm going to get into a little bit more detail, but here's how a bunch of the pieces connect together. So there's the aggregor browser, there's peer-to-peer protocols, peer-to-peer databases, community mesh networks, web archiving, static site publishing, and cooperative governance. So before we get too overwhelmed with all the words, let's break it down part by part. So at the core of everything is peer-to-peer protocols. This is how you can transfer data in a way where rather than having a third party that you both have to connect to exchange data with, you can connect to peers directly and exchange data directly with them. It allows you to create content locally and entirely self-sufficiently on your device and on your network and reach out from there. This changes how you can approach data within an application, where right now everything is based on the cloud and aggregating everything in large databases and large cloud services. So what's important is that when we rethink about our data in terms of peer-to-peer file transfer, we can destroy a bunch of the barriers to entry for creating new things, where instead of having to figure out DNS and hosting providers and backend databases and DevOps and all of these things, you can focus more on your data and who's connecting to who, and kind of forget about all of those extra skills that are no longer necessary. So the next important bit is how to actually use these peer-to-peer protocols. So personally, my favorite approach is to use the aggregor web browser, which is a web browser that lets you browse the web, but also lets you load web pages and web apps from peer-to-peer protocols. It also enables you to publish back to peer-to-peer protocols and connect to peers directly without needing a third-party signaling service like you would on the regular web. So I think of this as kind of the user-facing aspect of the peer-to-peer stack, where this is what people and end users will most likely interact with, rather than the engineers that are down in the weeds actually making these pipes connect. The other part is that peer-to-peer protocols end up being a really good content distribution network and application distribution network, where at the moment, if you have an off-grid scenario, if you want to create and publish and distribute a new application across a bunch of device types, you're basically out of luck unless you're using a central web server, and even then, it's going to have a lot of limitations. With peer-to-peer web apps, we can not only author content directly on our device, but that content could be new applications that others can reuse on their devices. So there's a few ways to do local first web apps. a lot of times people will prioritize loading web apps off of HTTP and just storing all of your data offline. Some folks also work on native apps, which you can then publish to app stores or install through package managers. Personally, I'm really interested in this plain and simple approach where people can slap together some HTML for a form, slap on some JavaScript to connect their buttons up, and use peer-to-peer protocols and databases for doing the heavy lifting of actually moving information around. What's cool is when we focus on the web, we suddenly have a way to make all of these applications cross-platforms with very little extra effort. We can get the same web app running on Mac, Linux, Windows, Android, and maybe even iOS once they get forced by the EU to actually allow us to have custom browser engines. So currently we're working in Agrigor on educational materials on how to make these local first web apps with these simple tools. So we're starting to roll out some small tutorials on how you can make your own kind of low skill, lo-fi web apps and just kind of get a feel for it. So what I'm really hoping is that instead of having super advanced engineers getting 300K salaries in Silicon Valley, maybe we can get some teens that are just getting into web programming and let them make stuff that's collaborative and that lets them share content without having to rely on all of these extra steps. So peer-to-peer and Agrigor are great for getting basic web content out, but it's actually not enough to make peer-to-peer and local first apps usable. What's really important, and which a lot of projects could stand to focus more on, is the database layer. So if you have a large amount of data, synchronizing all of it at once before you can use anything is just not a viable option. So that's where new primitives for peer-to-peer databases become really important. So one such primitive is IPLD-based Prolly trees. These are a sort of key value store that you can use as a basis for database indexing. And on top of that, you can build pretty much the same databases you might expect from SQL or Postgres or some data log-based thing if you're cool. This is also where we can start looking at reusing existing standards. So some people like it, some people hate it. There's the RDF standard and the linked data ecosystem from the W3C. There's a lot of cool stuff there. They already have schemas for data and for making it interoperable. I think there's a lot of opportunity to kind of bridge between that world and the peer-to-peer world. In particular, I think something like ActivityPub is just a really great target where we already have this large ecosystem of social data. What we can do is take a couple extra steps and suddenly it doesn't have to rely on a central server administered by some nerd and their access to the database. Instead, everyone could be the nerd. The other part is how to make the local first more than just your device and the internet. And that's where community mesh networks come in. So for those not in the know, we currently rely primarily on internet service providers to connect our devices together or network administrators within a single building. And this is usually a very top-down approach where you have to connect to, here in Canada, we have a duopoly, either Bell or Rogers. And if you can't, or if they decide to not reach out to your community, you're kind of screwed. So this is particularly difficult in regions where they're either very rural or in developing countries where a lot of ISPs just don't see the fiscal incentive to actually invest in these networks. And as well, even when ISP networks get built, they're often just reaching out to the cloud and to the internet and imposing more costs. What groups have been doing is instead forming community-based networks where you can get a bunch of routers together, point some antennas at each other, and start routing packets over the network. This fits really well with peer-to-peer protocols, where instead of everything having to go to Amazon East in order to share a cat picture, we can instead discover each other on our local network and exchange data directly with each other. So taking peer-to-peer protocols and matching them with mesh networks makes both of these systems more resilient and more powerful compared to using them in isolation with the current cloud-based internet. What's cool is there's also opportunities here for ad hoc mesh networks where instead of having the physical infrastructure set up by people and maintained, we can have our devices just connect to each other on the fly using Wi-Fi direct protocols or Bluetooth or similar. You don't actually need infrastructure in order to connect to each other. And when we kind of step past that point and when we focus on local content discovery, suddenly a whole bunch of extra costs and a whole bunch of extra barriers to exchanging information can be sidestepped entirely. Community mesh networks are also a great place to experiment with community governance, where if you have a physical network built by your local community and maintained by it, that's where cooperating with each other and sharing skills and resources is very important. So, however, this local first web stuff is not that great at the moment because there's nothing on it, and there hasn't been any obvious way to get stuff on it. A lot of people, when they want to use this tech, they want to actually do stuff. And so this is where web archiving can play a really great role, where instead of your community needing to reach out to the internet every time they want to load like a web page or some resource, you can have community-run web archiving tools such as Web Recorder's Browsertrix Cloud, which can automatically pull data from the web, crawl it, index it into a local peer-to-peer database index, and then disseminate it over the network. So that means if one community loads a particular web page, that can now be spread across the local network without having to do more costly trips to the internet and without having to worry about whether that server will still be reachable, like say 10 years from now. So right now, Web Recorder is working on a new spec on top of IPFS for deduplicating data across archives. This is going to allow us to have very large data sets that can aggressively deduplicate static assets like images and text and the such. This is also where peer-to-peer databases come in, where if you have a lot of community source data, this is where it's important to have a way to access it without having to have a central point of failure and central point of access, such as a regular search engine. This is where we can have decentralized search indexes where two communities can federate together and combine their search indexes, which can be loaded from either their backup nodes or from any devices within the networks that have copies of the search data. So the other avenue for existing content is to just start publishing to the peer-to-peer web. And so this is where the distributed press project comes in. The way it works is you have a server that's running somewhere or other, and you can send it a tarball for a particular website with all of your website static content, and it will go through the work of publishing across any peer-to-peer protocols it has access to, and also setting up a custom DNS server so that instead of having like garbled 52-character long domains, you can have nice ones like example.com or say example.local. Whoa. So distributed press is kind of a Trojan horse and also a bridge between what we have right now, where if you are a group that's already publishing static assets on the web, this is where you can just add a single step in your workflow and point a DNS record for the DNS link spec to the distributed press server, and suddenly you're publishing across IPFS, Hypercore Protocol, BitTorrent, and whatever other protocols we have coming. This is also a bridge between the existing web and this peer-to-peer and local first web, where instead of having an all or nothing approach, we can gradually start transitioning stuff. It's also a useful tool for local communities which want to have websites published with nice domain names without having to go through really difficult scenarios to actually get that DNS stuff working. Lastly, we're also working with this group called SUTI, based in Argentina, and they have a content management system which builds on top of Jekyll static site generation and gives you a graphical interface for actually authoring posts and modifying your theme. So this is a useful tool for groups that just want to push some content out and don't want to have to actually code or like build pipelines or whatever themselves, they can just make an account, take a template, and start publishing. This is also something that can be run on local communities for people that don't want to, again, do everything themselves. So getting all this stuff to work is pretty hard, and it requires a lot of collaboration. So this is where community governance is really important. Whenever we have community resources, we have the option of either having top-down governance, where you have some company that owns everything, that decides everything, that can change anything from under you, which is also easier to do with a lot of centralized protocols and systems just due to logistics. What we have with a holistic local first approach is now it's easier for people to start at smaller scales locally and build their infrastructure up and collaborate from a bottom up basis instead of top down, where you share data and resources with each other because you have a shared goal rather than because it's cheaper for a company. So this is also where cooperative governance in companies or decentralized autonomous organizations or just groups kind of working together and transacting can collaborate. Yeah, so that's kind of the picture. Hopefully this has given you a bit of an insight on how we can have a new foundation for people-first technology. Right now we're looking for funding and collaborators. If you're interested, feel free to send me an email or visit the website and learn more.
Questions? Oh, yeah.
What are your thoughts in terms of authentication for local first apps, especially with regards to Aggregor?
Yeah, so it's really difficult, is my main thoughts. Personally, I'm of the opinion that the social graph is valuable, and especially when you have these inscrutable, horrifying domain names with public keys, you're probably going to be finding content through people you trust. So if I send you a link to something, you know that at the very least I trust that content. So I want to really lean on the local first nature of trust. And so existing places where this has been learned is in the secure scuttlebutt ecosystem, where there's no central coordination for identity or for authentication or for trust. It's literally based on who you know and who you know that doesn't hate this person. So if there's content in a community that is identified as harmful, the community can point it out and people can start blocking it if necessary. This is where things like subjective moderation are really important, where rather than having a central moderation log organized by some central committee, you can opt into things based on who you trust in your community or who your friends are. There's a really useful article by Alexander Koble on, it's called TrustNet. So I'd strongly advise looking into that, where it's based on your local view rather than a top-down central view. So that's my main thoughts.
Cool. Any other questions? Oh, people moving back.
Hi, my name is Eugene. Love all the topics you've been talking about. Love those tech. My question is two-part. What's your attitude towards existing protocols and technologies, and how do you relate to them in terms of like Aggregor? For example, why not use Beaker Browser? I'm glad you brought up SSB. I was going to ask about that. Would you want to support something like that in Aggregor, or is that sort of out of scope? And how do you make that decision in general?
Yeah, so in terms of existing protocols, my only constraints that I've been focusing on is how we can make them work local first in terms of not having a strict reliance on third-party software. So a lot of blockchain-based content delivery things are kind of like in this gray area where I'm not opposed to integrating it, but if it requires like really expensive hardware to have it work in a local environment, then it's not really worth it. Past that, peer-to-peer protocols, great. Gemini is also in there, which is kind of like an alternative to Gopher, which is what the web could have been. Really things that are more focused on content addressing and loading content is what I've been focused on. Not so much on like things that don't have links or things that are just APIs. Beaker browser is great. Paul Frazee did a lot of great work, and a lot of the design decisions in Agrigore that I made are actually based on what I learned from using Beaker browser back when it was actively maintained. So sadly, it hasn't been actively maintained for a while. The other like active browsers in the space are probably Brave with their IPFS integration, but at the moment there aren't many that focus on writing back to peer-to-peer protocols. Integrating new protocols, if you have one that you think would be a good fit, reach out on GitHub. We've had a few things added that way so far. We've integrated Secure Scuttlebutt into Agrigore. At one point, we had GunDB as a protocol handler. And generally, it goes around figuring out how we can take the peer-to-peer protocol and apply this URL based paradigm where it's like, here's how you link to a resource, here's how you can use standard HTTP methods to either get data from it, use head to get metadata, or use stuff like put or post to upload stuff or mutate data. So that's been the main consideration. Yeah.
Hi. I found what you talked about with web archives really interesting. They sound like a kind of locally run CDN sort of thing. A lot of what I've seen in the peer-to-peer web space really seems to focus a lot on static content, whereas I feel like there's maybe some interesting things to explore around like more dynamic, like server-owned content. And I'm curious if you have thoughts or examples in the community of people exploring like how to archive server-run content without necessarily like server operators cooperating sort of thing. Does that make sense?
Yeah, that dynamic server-owned content is extremely hard. The closest we have right now is dynamic content, which is like in the form of single-page web applications, where you might have JavaScript pulling in data on the fly or modifying it. But outside from crawling server's backend, there's not that much out there. Or crawling a backend or building an offline first web app. One thing that I heard a lot, just talking about Beaker browser again, people would come in and be like, how do I run PHP in Beaker? Because it's like, we have URLs, we have peer-to-peer, how do I run my PHP server? And so one of the things that I'm excited about is projects like IPVM, where we could have WebAssembly, which could run whatever infrastructure or whatever code we want. And that WebAssembly might as well be a PHP interpreter, and it might as well be loading a SQL database over IPFS. And we could just run dynamic content that way, where we could generate it on the fly, on the edge, or in a distributed compute environment using IPVM and the technologies around there. Yeah, but sadly, without collaboration from server operators, there's no easy path that I'm aware of.
Maybe one more? Ramsey? Okay.
Hi. I wondered if you could speak to the what I see as a tension between the sort of local first approach, which, as you said, like leans on trust between people, and a lot of blockchain technology, which is sort of explicitly designed to be trustless. And I wonder if you see any bridges there, if they're just incompatible, or how they sit together.
Yeah, I think one thing that's important is to talk about consistency and what trust means in these contexts. Because in peer-to-peer protocols, there's still trustlessness in the sense that at the protocol layer, you don't have to trust peers to give you false data. In that content addressing and public key cryptography is used in most peer-to-peer protocols for verifying authenticity of data if you trust that root identifier. Personally, I think blockchains could have some use for cases where you really care about global consistency. So, like, for instance, financial ledgers, it makes sense. Doing that with peer-to-peer is just like not very easy. But at the same time, I think a lot of stuff gets shoved into blockchains, which doesn't need to. Because like you don't need consistent state for a lot of apps where it's a small community collaborating. And I think there's a lot of opportunity for blockchains to lean more on peer-to-peer and local first tech and for communities that use local first paradigms to either run chains or some sort of consensus mechanisms locally, or use some sort of like interchain bridges between communities. So I'm working for the Haifa Worker Co-op here in Toronto. Yeah, and so one of the projects they work with is called the Cosmos Network. And so the whole thesis of Cosmos, in my view, is instead of having like a single chain that has absolutely everything and proof of work with super expensive hardware that is like burning tons of energy, they use proof of stake and bridges. So we can imagine a scenario where we have chains that use stake in a community's token, bridging out to other nodes and kind of having interchain economics there. Personally, however, I prefer things that are free and that don't require money to operate. Because when we have money in a system, what we're saying is that this system is no longer scarce for those with money, and those without money cannot participate. So when we take that into the approach where people don't have a lot of money, or when we take the proof of stake approach where people with the most money can have the most stake, it means that we're disempowering everyone but the wealthy. So although I see there are uses for economic incentives, I'd like to see more things that don't rely on that as a first principle.
Awesome. Thank you, Mauve. Thank you so much. Woo!